last section of chapter 10 in your chemistry book, section 7, is on noble gases. These are very important. These gases are very unreactive. They don't react very easily because their last electrons are full in the last shells, and we went over that before. But let's look on the periodic table where these noble gases are. As you see here, they go clear over to the 18th, basically the 18th column here. So what do we have for noble gases? We will have, let me zoom in here, you see, helium, neon, argon, krypton, xenon, radon. All of these are noble gases, clear at the end, very unreactive. They don't like to react with anything, so they come in their natural state. So noble gases. Occurrence and properties are all monoatomic gases in unconfined forms, means they come in their form. So that means helium basically is found in natural gas in a concentration of 0.5% to 2.4% by volume. And this sum of the gas, we'll say basically by volume, some gas wells have as much as 6% of helium. Other noble gases are obtained in small quantities from liquid air. Helium, okay, when was helium discovered? Helium was discovered by Joseph Lochner and Pierre Janssen in 1868. And they were studying the spectrum of light from the sun, and they basically came upon the discovery of helium. From that point, not until 1894, argon was discovered, and then krypton was discovered in May of 1898. Neon was discovered in June of 1898, and xenon was discovered in 1898 of July. And radon was discovered in 1900. So all in a row, these noble gases were discovered in the 1800s, or late 1800s and early 1900. So let's look at some of the properties in table 4 here. So helium, melting point, you can see, is negative 272. And helium does not exist as a solid below this pressure. And the boiling point is 269, negative. Colorless gas and more abundant in the atmosphere. Abundance in the atmosphere of 5.2 parts per million. So neon, you can see here, the melting point similar to helium. It's colorless gas. And the abundance, abundance in the atmosphere, 18. Onto argon, and its melting point at negative 189 and boiling point at negative 186. So centigrade. And this is a colorless gas. Abundance in the atmosphere is 0.93. Abundance in the atmosphere, parts per million, 9,300. So krypton, we have krypton at negative 157 to 153 is the melting and boiling point, colorless gas. Abundance in the atmosphere is 1, so basically parts per million would be 1 per million. And then xenon, negative 12 degrees to boiling point at negative 108 degrees centigrade, colorless gas. So you can see the properties, and basically the parts per million are in this. You can see where some are quite a bit more abundant than others. So the compounds, due to their unreactive nature, none occur, no compounds, I should say, occur naturally. So They found and made compounds of especially xenon, as you see later on, but they were all manufactured in the laboratory. None became, basically you see happening in nature. So the first that they manufactured there, you can see here, was xenon, and we have xenon. First compound was xenon PTF6, synthesized in 1963. Later, xenon, all these different, and these last two being with the oxygen being very explosive. And also onto the freon. They combined it with oxygen, with fluorine here, and as you see later on, PTF6. So how they combined it, but you have to combine it in that laboratory to do this. So there were some of the compounds. Compounds of krypton and argon, such as KrF2 right here, have been prepared, and the radioactive reagent has formed fluoride, but helium and neon, those two noble gases, have never been made into stable compounds ever. So they've never been able to take helium and combine it into a compound, even in the laboratory. So the uses. Well, let's talk about some of the uses of starting with helium, okay? So helium is a lifting gas. You can put helium, of course, in balloons, and where will they go? Out into oblivion. They always lift airships in the midst. So helium being in some of the big, huge air blimps in the past. Helium is also, because of its boiling point, it also can be used as a coolant with extremely low temperatures are needed. Now you can use helium. It's used to dilute oxygen in air for deep sea divers using helium, and because it's less soluble and less dangerous than nitrogen. So helium for a deep sea diver is much safer than regular air. And helium is used also in welding. So all of these things, as you can see, in the midst helium. So let's go down here. Several noble gases are used in electric lighting. This is very important because incandescent light bulbs were commonly filled with a mixture of argon and nitrogen. And argon helped make the bulb's filament glow more brightly. And so they found that a lot of these noble gases were used in lights. We find out fluorescent lamps, actually, when added argon, would raise the pressure and the voltage and maybe make the light be brighter. So let's go on to the next page of these. Talk about, here we go, it's a picture of a neon sign. So some of the colors, so the colors of the neon signs, various mixtures of red make the neon colors. Argon signs add to the neon more of a blue color, neon being red, helium color of being a yellowish white. Helium argon together made an orange color, and neon argon was a deep lavender. So they found by mixing these noble gases together, they could make different types of lighting, and all of them kind of coming into the neon sign. Neon signs are electric discharge lamps that use various mixtures of noble gases to achieve a variety of colors. So you can see now that our neon signs. Neon and krypton lights, they use those lights in the airports. And xenon is powerfully used in arc lamps. Lasers, in fact, they use basically these noble gases in the lasers, which are concentrated beams of light, intense light with the noble gases. There's helium neon lasers that we use in the supermarket. When they check out, you'll see the red light as they're checking out through the scanners. These are lasers, kind of this crimson beam. And argon Argon actually is used in lasers too, and it's kind of the green beam, kind of a greenish beam. Excimer powerful lasers also use noble gases and halogens, and they have pulsed beats of UV ultraviolet rays that can be used for corrective eye surgery, laser surgery of the eyes. Also in computer chips, and they'll use these noble gases and lasers. So quite a few things. Radon, which is not used in lighting so much, but they've used the radiation source for cancer treatment. And also because it's produced naturally by the decaying of uranium, it's considered to be radioactive, so a lot of times with the radon, especially in the past, there would a buildup of radon in some home basements, and this was giving exposure to radiation in the midst. So radon can be a risk of especially lung cancer to people that smoke mainly. So, and also an argon-oxygen mixture helps remove undesirable carbon impurities from molten steel. So, and anyway, so let's look at some of these uses here. Some uses of the noble gases. Helium in liquid form is used as a very low temperature coolant, special gas mixers for deep sea diving, industrial applications such as inert atmosphere for welding, dilute gaseous anesthetics. Didn't know that. The filling of balloons, blimps, and other lighter than air crafts and lasers. Helium's used for quite a few things now. Neon signs, airport running ways, lasers. Argon filling incandescent light bulbs, which they don't do it now. They use fluorescent lamps mainly. Inert atmosphere for metallurgic operations such as welding, flushing oxygen from molten metals, lasers, that's argon. Krypton, used in the airport runways and approaching lights and high intensity flash bulbs. Xenon and krypton mixture is a high intensity short exposure photograph, flash tubes and arc lamps. So this all has to do with light, huh? And of course, radon, radioactive tracer in laboratory studies of chemical reactions and also in cancer treatment, but that's declining now. So there we have it. So what is the major use for helium? I would say helium is used for lifting, right? So lifting gas and also in deep sea diving, but mainly lifting. And then the noble gases, we already went over the uses right above here so you can review. So we're going to stop there with the noble gases, and we're actually finished with chapter 10. We could go on to the questions, which maybe I will here because we have some time, and I'm only going to go over some of them. It's not some of the more complex one. So what is the most abundant element in the universe? Hydrogen, right? Hydrogen. So name two primary ways in which hydrogen is produced commercially. Do you remember steam reforming? It's called steam reforming. Of course, you think of steam as, water and hydrogen coming out of the steam of the water. So steam refining. And the other is to replace like zinc, using zinc and with hydrochloric acid. That's the other one. So basically, but steam reforming you should know for hydrogen for the test question. What is hydrogenation and why is it used in some food products? It's adding hydrogen to things, right? And they especially use it in oils like margarines that have been liquid, and be able to make them firmer. They would process food to causing this processed food, and this hydrogenation would be make it more solid and easier to preserve it. So hydrogenation in food is not so good. Kind of processed food. What is the most abundant element in the Earth's crust? I hope you knew oxygen is actually. Number 5, what is the allotrope? Well, it's important that you know what an allotrope is. And basically, it's a different physical state of a certain element. Like you take oxygen, you have regular oxygen, and you have ozone, which is O3. And they're in different forms, so they're called allotropes because they look differently. Number 6, chemically, what is combustion? Well, combustion basically has to do with oxygen. When oxygen is united to something that's very explosive, that would be when you think of combustion with oxygen. Number 7, what is the purpose of the ozone layer? Well, God put together the ozone layer for what purpose? I would say for protection from UV lights, because ozone are very damaging ultraviolet light that is blocked by this layer of ozone. So, what element is the major component of air, and what percent does it constitute? When you think of air, you think of oxygen, but it's not oxygen. The major component of air is nitrogen. And what does it constitute? 78% nitrogen in the air. Why is nitrogen fixation important to agriculture? Do you remember what nitrogen fixation was? Basically, it's when nitrogen, as the nitrogen cycle comes, bacteria is important on certain plants, especially legumes like beans and peas and stuff. And it produces this protein, which is a type of amino acid. And so it fixates nitrogen into the soil and into the plants. So nitrogen fixation. So let's see. Excuse me. What 3 elements are the main nutrients provided by fertilizers? Of course, we know nitrogen, but remember, there's always, you look on a fertilizer bag to see, you'll see nitrogen, and then the nitrogen would be number 1. And which is let's see. So nitrogen, the 3 elements would be nitrogen and potassium and phosphorus. So the first number would be nitrogen, the next would be the potassium, and then phosphorus. Number 11, what compound is most of the nitrogen produced in the United States used to make ammonia? Nitrogen is very used to make all kinds of ammonia, and the process that it uses is called the Haber process. Remember I said hydrogen and nitrogen coming together to make ammonia is the Haber process. So Haber. Number 12, what industrial chemical is produced through the Oswald process? The Oswald process takes the chemical nitrogen and makes it into nitric acid. So both of these, the Haber process and the Oswald process, have to do with nitrogen. So going on to number 13, name 3 high energy nitro compounds. Well, right now I can think of nitroglycerin and dynamite, right? So at least 2 of them there. So you can look at the other one. Name the 2 most important allotropes of phosphorus. Now we're talking about phosphorus. Phosphorus has 2 allotropes that look differently, but they're both phosphorus. So that's what allotropes are. And one is white phosphorus, and the other is red phosphorus. Those are the 2 different allotropes. And which is more stable? Basically, the one that would be more stable would be, I think, would be the red. Let's see, 2 must have red and white. So I can't recall. I think it's, but remember, oh yes, the red is more stable. Remember, it's the long bands of phosphates all together, so you'll have very more stable with the phosphate. List 3 uses of phosphates. What are phosphates used for? So phosphates, can you remember some of those things? Well, they use it to manufacture matches for sure. The synthesis of phosphoric acid and detergents and ammunition and bullets and bombs. Also, phosphorus is in in our cells. ATP has phosphorus in it. So it's quite a as for lists of phosphates, fertilizer, we went over that too, can be phosphorus. Remember, it's nitrogen, phosphorus, and potassium. Number 16, what is the main use of sulfur? The main use of sulfur, 85%, is used to make sulfuric acid. So, because sulfuric acid is actually an indicator of how well the industry is doing in a country, because it's so important that we use that, because sulfuric acid is used for so many things. Number 17, what is the most reactive halogen? I hope you knew fluorine. Fluorine, of course, is the most reactive element of all the elements, not just the halogens. Number 18, what is the composition of household bleach? So when we talk of household bleach, I hope it's the hypochlorite ion. Remember that? So hypochlorite ion that comes in and replaces, the other elements in that midst of it to cause that antiseptic, also the bleaching, the color. So on to write these formulas. Let's see the formulas. I was going to go ahead and show you these. All right, there we can see it better. Ammonia, NH4, you can get these all from your nitric acid. Anytime you have an H hydrogen to nitric acid here, this is nitric acid here. So sulfuric acid, another acid H there with hydrogen sulfate, sulfuric acid. Sodium nitrate. Here's sodium is Na and nitrate. Ozone is O3. Cesium superoxide. I wasn't sure about that one, so let's pass on that one. Phosphoric acid. Again, we have hydrogen with phosphate. PO4 being phosphate. Ammonium nitrate. And on to sodium hypochlorite. Sodium there. And of course your hypochlorite. Remember, that is that bleaching. So, all right. Which noble gas is most common in the atmosphere? Which noble gas? Helium, right? So, hey, we went through these questions, so they may be in the test. The next thing we'll be doing is the test. We're going to go over the next chapter first, because I think the test is on 2 chapters. So, but we're finished with chapter 10.